Okay, ladies and gentlemen, the first part of Supplement D gives us 10 basically descriptions of what we want to have happen to a function. So on the first function, we're being told that f of x is 1 over x and we're shifting it up 4 units. If you're shifting a graph up 4 units, that does not affect the x value, that affects the y value. So all we're really doing is we're adding 4 to 1 over x. And that's why when you look at your answer key, notice that your answer to question 1 is the function g of x equals 1 over x plus 4. It shifted up 4 units. Now, when you look at question 2, f of x equals x cubed is the original graph, and we're shifting it 6 units to the right. Now, if we're moving something to the left or right, that means the x value is affected. So my new function that we're creating would have to affect the x value. And if you remember what we did in class, the x value when it's being affected is always backwards. So if I say 6 to the right, you're not adding 6 to x, you're subtracting it. So the correct answer to problem number 2, as you can see on your answer key, would be g of x equals, and then in parens, x minus 6 raised to the third power. Notice why we have to put the x minus 6 in parens. The minus 6 goes with the x, and if I didn't put it in parens, then it would be outside the parens, which means it would be a y value change, not an x. Okay? So that's why that's the correct answer. Let's look at question 3. We're taking the function f of x equals the square root of x, and we're reflecting it across the y-axis. Now what I want you to picture is this. If you picture an ordered pair in quadrant 1, just any ordered pair you want to in quadrant 1, if I reflect it with respect to the y-axis, okay, so it's moving from quadrant 1, we're reflecting it, so it would end up in quadrant 2. The y value would not change, the x value would change. Okay? So basically what's happening is the x value is changing, let's say from quadrant 1 it's changing from a positive to a negative. Well, the way you would make this graph, the way you would make this graph, now I saw that cheese, I'm hungry. The way I would make this graph reflect across the y-axis is I would take its x value and multiply it by negative 1. So that's why the correct answer, when you look at their paper, the correct answer is g of x equals the square root of the opposite of x. Anytime you're reflecting across the y-axis, it's the x value that gets multiplied by negative 1. So that would be our correct answer for reflection. Okay? Now, in problem 4, they give you the function f of x equals x squared. They want you to reflect it across the x-axis. Now this time what I want you to do, I want you to picture a point, any ordered pair you want to in quadrant 1. Okay? Picture that. If I cross the x-axis, the x value is not changing, it's the y value that's changing. The y value is changing from positive to negative. So anytime I'm reflecting something across the x-axis, I'm multiplying the original function, which is the y value, by negative 1. That's why my answer would be g of x equals, and it's actually negative 1 times x squared, which is read opposite of x squared. Okay? And question 5, if I'm taking the original graph that is absolute value of x to start with, and I'm shrinking it vertically by a factor of 1/2, okay? What that basically means is I'm multiplying it by 1/2. So g of x equals 1/2 times the absolute value of x. Now, if you don't know what that would do on your calculator, it's a good idea to take out your calculator, graph the absolute value function, then graph for y sub 2, graph half of it, and what you're actually going to see is that it's still a V shape, but when you graph the 1/2, the branches are wider apart. And that's basically called a compression or a shrinking. You kind of, for lack of a better phrase, you kind of squish the original graph down by a factor of 1/2. You've changed the y value so that the y value is flatter. It's half of what it used to be. It's half as high. So the branches come further apart. Okay, we'll do 6 through 10 on the next video.